In this video, I'm going to guide you through a phonology problem that is a bit more challenging than the biblical Hebrew problem. I covered the basics of phonological analysis in the biblical Hebrew video, so make sure you've watched that first before you watch this one. I'm going to rush through the basics and focus on the more challenging aspects of the analysis. This problem is more challenging for two reasons. Firstly, because we're looking at 3 similar sounds rather than just 2. And secondly, because the conditioning environments are more complicated. So, let's look at the question and the Korean data. We are asked to consider the sounds s, sh and z and see if they contrast or are in complementary distribution. Remember that we should start by putting the problem in context. Why would we be suspicious that s, sh and z might potentially be allophones of a single phoneme? Because they're similar sounds. They share features. In this case, they share both manner and place features. All 3 sounds are fricatives, so they're all plus consonantal and plus continuant. Due to their place of articulation, they are also all plus strident in terms of manner. When it comes to place of articulation, they're all plus coronal. So, how do they differ? In terms of place, s and z share features with each other that they do not share with sh. That is, s and z are both plus anterior and minus distributed, whereas sh is minus anterior and plus distributed. S and z differ in only one feature, that of voice, which s shares with sh as both a minus voice. So, now to start looking at our data. Remember that we make a table with 3 columns for each of the sounds in question so that we can indicate the before and the after environments for each of the sounds. I've indicated all of the before and after environments here. A reminder that the hash symbol means a word boundary, so means that the sound occurs either at the beginning or the end of the word. In this case, before s and sh, so the beginning of the word. Once we have looked at every example of each sound and indicated the sound that occurs before and after in each case, we are ready to compare the before and after environments to look for evidence of contrast or complementary distribution. To start by comparing the before columns, we see that s and sh have something in common. Both occur at the beginning of a word and after u. There is therefore no evidence from the before environment that s and sh are in complementary distribution. When we compare z with s and sh, we see that z has nothing in common with s or sh. Only n or ng can occur before z, whereas n or ng do not occur before s or sh. This gives us evidence that z is in complementary distribution with s and sh. We now want to compare the after columns to see if there is evidence that s and sh are in complementary distribution. Note that we do not need to compare the after column for z, as we have already established that z is in complementary distribution with both s and sh. We see that s and sh have nothing in common. After s, we get a, o, or u. After sh, we only see e or e. This is therefore evidence that s and sh are in complementary distribution. So we've established that the before environment is conditioning for z, but the after environment is conditioning for s and sh. Which sound should we choose to represent the phoneme? We choose s, as it has a much wider distribution. It occurs at the beginning of a word and after a vowel and a consonant, and has a greater range of vowel sounds that can occur after it, compared to sh. And z only occurs after 2 sounds, n or ng. We now need to work out how we can generalize the environments to write the phonological rule. The conditioning environment for z is after a nasal consonant. This should be obvious without needing feature charts, as we only have to consider the two sounds, the alveolar nasal and the velar nasal The environment conditioning sh is more complicated, as there are different vowels that occur after s and after sh. So we need to use our feature charts. We arrange the feature chart with the vowels occurring after s together and after sh together. We can then compare the features and see if we can establish a conditioning environment. In this case, it is not totally straightforward. If it was, we would be able to see one row that contrasts completely for s and sh. In other words, a row that has all minus for one sound and all plus for the other. We don't get that, but we can see that e and e are both plus front, and almost all the other vowels after s are minus front. The exception is a, which is also plus front, but a is plus low, and both e and e are minus low. So indicating both of those features as the conditioning environment for when sh occurs will enable us to write a rule that accounts for all the data. So we can now write the phonological rule. The rule states that the rule that accounts for the fact that s becomes voiced z due to the environment that precedes it, a consonant which is plus nasal, whereas s becomes sh due to the environment that follows it, a vowel that is plus front and minus low. And then we get s elsewhere, that is in all other environments.